Secondary Examination 2018. Subject Mathematics. Full marks 100. Pass marks 33. Time 3 hours. Attempt all questions. The figures in the right margin indicate full marks for the questions. Ye thangmana kanda lariba figures sing asina questions sing asigi full marks sing. For question numbers 1 to 6, write the letter associated with the correct answer. Question 1 dagina 6 fawbadi achumba answer dugi chanaba letter adu iyo. Question number 1. If f and g are functions defined from r to r by f of x equal to x plus 1 whole square and g of x equal to x square plus 1, then the value of fog of minus 3 is fog of minus 3. F of g of minus 3 is equal to f of g of minus 3. G of minus 3 is minus 3 whole square plus 1, whose value is 10. F of 10, that is 10 plus 1 whole square, 11, 121. Correct answer is B. Question number 2. The value of sine inverse of 1 by 3 minus cos inverse of minus 1 by 3 is sine inverse of minus 1 by 3 gidi. This is equal to sine inverse of 1 by 3 above 1 is equal to pi minus sine of cos of 1 by 3. Cancelling, we get pi by 2 minus pi, that is minus pi by 2. Correct answer is A. Cos inverse of minus 1 by 3 is equal to pi minus cos inverse of 1 by 3. Using this formula, we get sine inverse of 1 by 3 plus cos inverse of 1 by 3, whose value is pi by 2, minus pi, that is minus pi by 2. Correct answer is A. If A is equal to this is such that A square equal to I, then which one is true? A square is what? A square is I, it is given. Then A square is A into A, whose value is I, taking square root. Modulus of this, modulus of this, modulus of I is 1. Then whose modulus is A square BC, which is also A square minus A square minus BC, whose product is 1. Correct answer is C. For question number 4, the volume of a spherical balloon is increasing at the rate of 25 cm³ per second. The rate of increase of its surface area when its radius is 5 cm is spherical balloon amagi volume hengatpagi changsi second khudingi 25 cm³ ni. Surface area hengatpagi rate putu radius na 5 cm oiba matamda surface area is for surface area 4 pi r square, then ds by dr is equal to I pi r. Correct answer is B. dv by dt is this, s is 4 pi r square, dv by dt, b is this. Differentiating with respect to t, we get this, from which we have to put r equal to 5 and solve dr by dt, which is 1 by 4 pi. Therefore ds by dt is equal to dr by dt 1 by 4 pi. Cancelling this, we get 10 cm square per second. Correct answer is B. The value of this indefinite integral is B. 4 is 2 square and x power 4 is x square whole square. Put x square equal to z and solve, we get this. Correct answer is B. The line this is parallel to the plane this. Piramiba line asiga parallel to plane the makagi sing asidagi khallo haibani. Then 3 line asigi di 4 5 ni. Plane asigi direction ratio di 2 1 minus 2. A correct answer to D hoigani. Using perpendicularity condition palaga. Define identity element for a binary operation defined on a set. Identity element binary operation amagi identity element defined to 1 mark. An element E belongs to A for a binary operation asterisk on set A is said to be an identity element if A asterisk E equal to E asterisk A equal to A for all A belongs to A. This element E is called identity element for the binary operation asterisk on the set A. I write the value of sine of 10 inverse of 3 by 4 1 mark. We have to put x equal to 10 inverse of 3 by 4. 10 inverse of 3 by 4 do later amaga manahalabadi 10x equal to 3 by 4. Then given expression becomes sine x. We have to express sine x in terms of 10x. 10x into 1 by sec x. Sec x again equal to root over 1 plus 10 square x. Now sine x is completely expressed in terms of 10x. Put 10x equal to 3 by 4 and simplify, we get 3 by 5, which is the required value. Define identity matrix. 1 mark. A scalar matrix whose diagonal elements are all 1 is called a unit matrix. Scalar matrix whose diagonal elements are all 1 is called a unit matrix. Then if A is a matrix of order 2 by 3 and B is a matrix such that A transpose into B equal to product of B into B and A transpose both are defined, then what is the order of B? Let M by N be the order of B. A is a matrix of order 3 by 2 and B is of order M by N. So product A transpose B is of order 3 by N. 3 by N. And M equal to 2. That gives the value of M is 2. Similarly, B product B and A transpose is of order what? A transpose is 3 by 2. 3 by 2 into M by N. And we have N equal to 3. So the order of B is 2 by 3. Question number 11. State Lagrange's mean value theorem. 1 mark. If a function f is defined over the closed interval AB is such that it is continuous in the closed interval AB and derivable in open interval AB, then there exists at least one point C belongs to open interval AB such that f dash of C equal to f of B minus f of A whole divided by B minus C. To define increasing function, a function f is an increasing function in the interval I if x1 less than or equal to x2 implies f of x1 less than or equal to f of x2 for all x1 x2 belongs to I. Write the value of definite integral x cube sine cube x dx between minus pi by 2 whose mark is 1. This is 0 as f of x. The integrand is an odd function. Using properties of definite integral, we have its value is 0. What is meant by solution of a differential equation? A function y equal to f of x is a solution of a differential equation if the differential equation is satisfied by the values of y and its derivative. Y equal to f of x haiba function nama differential equation namagi solution ni haigani mahak amasung mahaki derivative singna differential equation adubu chumhallabadi. Define the vector product of two vectors, 1 mark. The vector product of two non-zero vectors a and b is denoted by a cross b and is defined as a cross b equal to magnitude of a into magnitude of b into sine of theta times of n k, where theta is the angle between a vector and b vector such that theta lying between 0 and pi including the two ends, and n cap is a unit vector perpendicular to both a vector and b vector. Question number 16. For a binomial probability distribution with parameter n, p and p plus q equal to 1, what are the mean and variance? For binomial distribution with parameter np and p plus q equal to 1, mean is np and variance is npq. 17. Let Z be the set of integers so that the relation R consisting of order pair A B such that A, B belong to Z and A plus B is even is an equivalence relation. 3 marks. Here R equal to this. For X belongs to Z, X plus X equal to twice X, which is an even integer. Therefore, order pair XX belongs to R for all X belongs to Z. Therefore, R is reflexive on Z. Next, let order pair XY belongs to R. That gives X plus Y is equal to even integer. Implies Y plus X is again even integer. Then Y X order pair belongs to R. Therefore, R is symmetric on Z. For transitive, let x, y, yz belong to R. Then by definition, x plus y plus z are even integers. Their sum is also an even integer. That is x plus twice y plus z is even integer. Implies x plus z is even integer. Implies order pair xy belongs to R. Therefore, R is transitive on Z. Hence, R is an equivalence relation on Z. Question number 18. So did 2 times of tan inverse x equal to sine inverse of twice x by 1 plus x square equal to cos inverse of 1 minus x square by 1 plus x square. 3 marks. Let tan inverse x equal to a. Then x equal to tan a. Now, sine of twice a is equal to twice of tan a by 1 plus tan square a. Put implies twice a equal to sine inverse of twice tan a by 1 plus tan square a. Tan a is equal to x and a is equal to tan inverse of x. First part is over. Also, we have cos twice x in terms of tan a is this. Implies twice a equal to cos inverse of this expression, and again a is equal to tan inverse of x, tan a is also equal to x. Therefore, first and last part are equal. Thus, 2 tan inverse x equal to sine inverse of twice x by 1 plus x square equal to cos inverse of 1 minus x square by 1 plus x square. 19. Find dy by dx if x to the power y into y to the power x equal to 1. Taking logarithmic on both sides, we get y times of log x plus x times of log y equal to log 1. But we know that log 1 is 0. Differentiating both sides with respect to x, we get y into log derivative of log x, that is 1 by x, plus log x unchanged into derivative of y, that is dy by dx. Then next, x remains unchanged, log y is derivative is 1 by y and into dy by dx, plus log y remains unchanged into derivative of x, that is 1, and derivative of 0 is again 0. Solve dy by dx, combine dy by dx, and solve dy by dx, we get this, which is the required derivative. Question number 20. Write the steps for solving a homogeneous differential equation. Write the steps for solving a homogeneous differential equation. Stepwise method for solving a homogeneous differential equation. Step 1. Write the given differential equation as dy by dx equal to f of xy by z of xy, or x to the power n times of f of y by x whole divided by x to the power n times of z of y by x. Next, put y equal to bx, that is y by x equal to b, so that dy by dx equal to b plus x db by dx. And substitute y by x equal to b, so that dy by dx equal to b plus x db by dx, obtained in earlier step in the differential equation. Step 4. Separate the variables and integrate. Step 5. Replace b by y by x in the solution obtained in step 4 and get the required solution. Question number 21. Let a equal to this, b equal to this, and c equal to this. These three vectors are expressed in its components. That prove that a vector dot b cross c is equal to this. This is called scalar triple product. Firstly, we have to find out b cross c, which is written in determinant form. Expand in the first row, we get this. Next, a dot of b cross c is scalar product of this vector with a vector. That is this. For this, we have this long expression, which can be written in this form. Hence, proof. Question number has two children. Find the probability that both the children are boys if it is known that at least one of the children is a boy. Yamdrabada angang anidugi manungda amadi nupa machani haina piramlabadi animak nupa macha oigani haibagi probability putu haibani. Here S equal to BB, BZ, ZB, ZZ, where B stands for boy and Z for girl. Let X, even children are boys. Y, even that at least one of the children is a boy. Then S consists of BB and Y consists of at least one of the children is a boy or the B or Y. Then their intersection is BB only. Then P of X intersection Y is 3 by 4 and P of Y is 3 by 4. Therefore, P of X by Y is P of X intersection Y by P of Y. Putting their respective values and solve, we get 1 by 3. This is the required probability. Question number 23. Prove that every square matrix is uniquely expressible as the sum of a symmetric matrix and a skew symmetric matrix. Square matrix khudingmak symmetric amaga skew symmetric amaga ani gi samda phongdokpa yai. Hariba matrix animak unique and unique oigadabani ani suba ahum sura phongdokpa yadi. 4 mark. We have A equal to half of A plus A transpose plus half of A minus A transpose. Now transpose, taking transpose of the first matrix, we have half of A plus A transpose whole transpose using this formula. Next, using this formula, we get half of A transpose plus A transpose of transpose, whose value is A. By using this property and matrix addition is commutative, we can put it in A plus A transpose, whose transpose is itself. Thus, half of A plus A transpose is a symmetric matrix. Again, we have to take transpose of the second matrix. We have this using this property similarly just above. We have minus half of A minus A transpose, whose transpose is minus times of itself. This shows that given matrix is a skew symmetric matrix. First part is over. For uniqueness, second part, if possible, let A can be expressed X plus Y, where X is a symmetric matrix and Y is a skew symmetric matrix. Therefore, its transpose is X plus Y, its transpose is X transpose plus Y transpose. But X is a symmetric matrix whose whose transpose is X itself. Y is a skew symmetric matrix whose transpose is minus Y. But we have learned that A equal to X plus Y, and also we have found that A transpose equal to X minus Y. Using these two properties, we have X equal to half of A plus A transpose, which is equal to P, and Y equal to half of A minus A transpose, which is equal to Q. X and P are same and Y and Q are same, which contradicts our assumption that A can be expressed in another matrices. Hence, A is uniquely expressible as the sum of a symmetric matrix and a skew symmetric matrix. For question number 24, using integration, find the area of the smaller region bounded by the curve x square plus y square equal to 1 and the line x plus y equal to 1 for marks. Application of integral question. Here the curve is this and x plus y equal to 1. We have this picture. We have to find out the shaded region. Their point of intersection. Clearly we know that they two intersect at A whose coordinates are 1, 0 and at B whose coordinates are 0, 1. Therefore require area of shaded region, which is equal to area of this portion of the circle between x equal to 0 and x equal to 1 and x-axis, minus area of this area formed by this line between x equal to 0 and x equal to 1 and x-axis. That is this, whose integrand is using standard integrand. We have this whose integrand is x, whose integrand is x squared by 2. We have put x equal to 1, we have this, and x equal to 0, we have this. After calculating, we have 1 by 4 times of pi minus 2 square units. Question number 25. Solve the differential equation given that y equal to 1 when x equal to 0, 4 marks. The given differential equation can be written as implies dy by dx plus 1 by of 1 plus x squared times of y equal to e to the power 10 inverse of x whole divided by 1 plus x squared. This is a linear differential equation. Therefore, its integrating factor is e to the power integrand of p, that is 1 by 1 plus x squared dx, whose integrand is 10 inverse x. Therefore, the required solution is y into integrating factor equal to integrand of this expression into integrating factor dx plus c, which is equal to this. Put 10 inverse x equal to z so that its derivative is 1 by 1 plus x squared dx equal to dz. We have this whose integrand is e to the power twice z by 2 plus c, but the value of z is 10 inverse x. When x equal to 0, y equal to 1, put these two values in the above solution, we have c equal to half. Therefore, the particular solution is this. 26. If a vector, b vector, c vector are three mutually perpendicular unit vectors, then prove that angle between a vector and a vector plus b vector plus c vector is 1 by root 3, 4 marks. These three vectors are unit vectors as well as they are perpendicular to each other. Therefore, their magnitude must be 1 and their dot product should be 0. Now, modulus of a vector plus b vector plus c vector whole square, whose expansion is equal to this, and whose value is 1, whose value is 1, whose value is also 1, whose value is 0, 0, 0. We have 3. Therefore, modulus of a vector plus b vector plus c vector is root over 3, positive value. Let theta be the angle between a vector and the sum of these three vectors. Then cos theta is equal to their dot product, the whole divided by product of their magnitudes. But their dot product is this, whose value is found to be 1, whose value is found to be root 3. Numerator a dot b is 0, a dot c is 0, a dot a is 1. We have cos theta equal to 1 by root 3. Therefore, theta equal to cos inverse of 1 by root 3. We have to write here cos inverse. Question number 26, alternative or using vector, find the area of the triangle whose vertices are this. We have to use vector. Here A equal to this, B equal to this, C equal to this. We have AB vector equal to this. AC vector equal to this. Therefore, their cross product is this. Taking their modulus, we have root over 165. Therefore, area of the triangle ABC is half magnitude of their cross product, that is this square units. Question number 27. Find the distance of a point A with position vector A vector from the plane R vector dot n vector equal to Q for mark. Let R vector dot n vector equal to Q be the plane and let P be any point in the space. Let PL be perpendicular from P on the plane and L the foot of the perpendicular. Let a vector be the position vector of the point P. Then OL is equal to OP vector plus PL vector. OP is replaced by a vector, PL remains unchanged. Since n lies on the plane, this n lies on this plane, therefore OL vector equal to n vector equal to Q, but OL is equal to a vector plus PL vector with n vector equal to Q, from which we have a vector dot n vector plus PL vector dot n vector equal to Q, and PL scalar product of these two vectors is magnitude of this vector into magnitude of this vector into cos theta equal to Q. A vector dot n vector plus whose value remains unchanged, which is also remains unchanged, theta. Why? Assuming PL and n to be like vectors, PL and the n vector to be like vectors, they have their angle between them is 0, that is cos of 0 is 1. PL equal to whose value which is replaced by only Pn, then Q minus a vector dot n vector divided by magnitude of n vector. Hence, the perpendicular distance of the point P whose position vector is A from the plane R vector dot n vector equal to Q is given modulus of Q minus a vector dot n vector by magnitude of n vector. 28. Find the shortest distance between the following pairs of parallel lines. These two lines are parallel as these vectors are proportional. Here are equal to this. First line is this, second line is this, from which we have A1 vector equal to this, B vector equal to this, A2 vector is equal to this. These two are same, which is replaced by B. Also A2 vector minus A1 vector, we have this. Now A2 vector minus A1 vector cross B vector. Using this determinant and expand in the first row, we get this. Therefore, shortest distance, using this formula, put their respective values, we have square root of 5 by 29. Question number 28O. Find the equation of the plane through the point this, and parallel to the line this. We have A1 is equal to this, A2 equal to this. A2 minus A1, we have twice ik plus twice jk plus thrice kk. A vector parallel to the given line is B vector equal to ik minus twice jk plus thrice k. Therefore, a vector normal to require plane is n vector equal to A2 minus A1 cross B vector. Using this determinant and expand in, we have 12 ik minus thrice jk minus 6 kk. Therefore, the required equation of the plane is R vector dot n vector equal to A1 vector dot n vector. Put their respective values. We have this 4x minus y minus twice z equal to 6. Question number 29. If A equal to this 3 by 3 matrix, find A inverse. Using A inverse, solve the system of linear equation this and this. 6 marks. Determinant of A equal to 2 which does not equal to 0. Therefore, A inverse exists. Also, cofactor of the first element 2 is denoted by A of 1, 1 whose value is 2. Cofactor of this 1 is 2. Cofactor of this 1 is minus 4. Cofactor of 2 is also minus 1. Cofactor of 0 is also minus 2. Cofactor of this 1 is also 4. Cofactor of this 0 is 1. Cofactor of this minus 2 is 0. Cofactor of this minus 1 is minus 2. Therefore, A inverse is equal to 1 by determinant A into adjoint A. We have this inverse. The system of equations can be written in matrix form as x equal to A inverse of B. Put there x is color matrix formed by unknowns and A inverse is equal to this and B equal to color matrix formed by no constants 3 5 1 3 5 1. Simplify, we get 1 minus 2 3, equating these to x equal to 1, y equal to minus 2, z equal to 3. We have solved the simultaneous equations using the inverse of the given matrix. 30. Prove that the function defined as f of x equal to this when x does not equal to 0, whose value is 0 when x equal to 0, does not equal to 0. When x equal to 0 is continuous but not derivable at x equal to 0. 6 marks. Limit of f of x tends to 0 from left is equal to this. This which is product of two functions. Therefore, limit of first function is 0. Limit of next function is this, and 0 into something is 0. Similarly, right hand limit at 0 is this. For this, we have to divide e to the power 1 by x in numerator and denominator. We get this. And taking limit, we have 0 for this 1 minus 0 by 1 plus 0. 0 into a finite number is 0. F of x is also 0. These three values are equal, so f of x is continuous at x equals 0. This must be 0. This must be equal to. For derivability, left-hand derivative at 0 is whose formula is this. Put their respective value, taking limit, we get minus 1. Right-hand derivative at 0 is denoted by rf there 0, whose formula is this. Put their respective values and divide e to the power 1 by x in numerator and denominator. We have this, taking limit 1 minus 0 by 1 plus 0, whose value is 1. Therefore, left-hand derivative at 0 and right-hand derivative at 0, these two are equal. Are not equal. Are not equal. Therefore, f of x is not derivable at x equal to 0. 31. So that the volume of the largest cone that can be inscribed in a given sphere is I by 27 of the volume of the sphere. 6 marks. Let ABCD be the cone inscribed in a sphere of radius r and center O. Let B be the volume of the cone and OB equal to x. OB equal to x. Then volume is 1 by 3 pi r square minus x square times of altitude is r plus x. Expand. Taking derivative with respect to x, we have dv by dx. For its derivative is this, and taking again its derivative with respect to x, we get d square v by dx square equal to this. We have this. For maxima or minima, dv by dx equals 0, we have quadratic equation in x. So factorize and solve x equal to r by 3 or x equal to minus r. Therefore, x equal to r by 3. Since x equal to minus r is invalid, x cannot be negative number. When x equal to r by 3 implies second order derivative is automatically a negative value. Thus, b is maximum when x equal to r by 3. The maximum volume of the cone is put the value of x, that is r by 3 in this formula, and Evaluate, we get this 8 by 27 times the volume of the sphere. Hence proof. Question number 31O. A window is in the form of a rectangle surrounded by a semicircular opening. The total perimeter of the window is 10 meters. Find the dimensions of the window to allow maximum light through the opening. 6 marks. Let ABCD be a rectangle. ABCD be a rectangle. And a semicircle is drawn with CD as diameter. CD na diameter of a semicircle na may Let AB equal to x meter and BC equal to y meter. Therefore, the perimeter of the window is x 2 times of y plus semi-vertical angle, semi-circle, semi-perimeter, twice pi pi x by 2, which is given as 10. From which we have y equal to this. Let AX be the area of the window. Then AX is XY, area of the rectangle, plus area of the semicircle. This is this. We have this y. Put the value of y in terms of x and simplify. We get this. Taking derivative with respect to x, this again taking derivative a dash x with respect to x, we have this. For maxima or minima, a dash x equal to 0 implies this, from which we have solved x equal to 20 by pi plus 4. When x equal to 20 by pi plus 4, a double dash of x less than 0, it is always negative. Therefore, a of x is maximum when x equal to 20 by pi plus 4 meter and y equal to, put the value of x here and solve y equal to in terms of pi is 10 by pi plus 4 meter. The dimensions of the rectangle are 20 by pi plus 4 meter by 10 by pi plus 4 meter. Question number 32. State 6 properties of definite integrals. 6 marks. 6 properties of definite integrals are: integral of f of x dx between a to b is equal to sum of these two definite integrals, where c is lying between a and b. Property 2. Definite integral whose value is equal to the definite integral of f of a plus b minus x dx. Property number 3. 0 to a f of x dx is equal to integral of f of a minus x dx between 0 to a. Property 4. Definite integral of this equal to sum of these two definite integrals. Property number 5. This definite integral equal to 2 times of this if f of twice a minus x equal to f of x, whose value is 0 if f of twice a minus x is minus f of x. Number 6. This value is equal to 2 times of this definite integral if f of x is an even function, whose value is 0 if f of x is an odd function. 33. Evaluate the indefinite integral. We have to resolve the given fraction 1 by x cubed plus 1 expressed in this form. As for linear, we have to put a. For quadratic, we have to put bx plus c. Multiply both sides by x cubed plus 1, we have this, which is an identity in x. Put x equal to minus 1, 0, 1, we have these three equations. Solving a, we have 1 by 3, c equal to 2 by 3, b equal to minus 1 by 3. Put these values in the above expression and taking integral on both sides, we have this, which is equal to this. For this, we have this. Then expand this in this form. Taking their integrals, we have this. Here I1, where I1 is equal to this. Make a quadratic ama semasi aduga koina standard integral ama phange 1 by a 10 inverse of x by a formula panjilo integral pocha si value se matak sinjalasi. Therefore, given indefinite integral equal to this. 34 or 33. Or evaluate integrand of this. Put x equal to a tan square theta and its derivative with respect to x gives the x equal to twice the tan theta into sec square theta d theta. Given definite integral becomes this, and evaluate these values, we have this. Taking integration by parts, this theta is the first function, this is the second function. Applying integration by parts, we have this, and for this we have this, for this we have this. Sec square theta whose integral is tan theta. Tan theta becomes tan square theta equal to x by a. Put their respective values in terms of x, we have this. 34. In a school, scholarship is to be given to the students of 11 and 12 classes. It is decided that at least 5 students from 11 class and at least 4 students from 12 class should get the scholarship. Each scholarship holder of 11 class will get rupees 300 per month, and each scholarship holder of 12 class will get rupees 400 per month. The total number of scholarship holders should not be less than 10 but should not be greater than 15. How many students of each class be selected so as to maximize the amount of the scholarship? Solve the problem graphically. Graph paper will not be supplied. 6 marks. Let x and y be the number of students to be selected from 11 and 12 classes. The problem is to minimize z or maximize z equal to 300x plus 400y. Subject to the constraints, x should be greater than or equal to 5, y should be greater than or equal to 4, and x plus y whose values should be lying between 10 and 15. X and y cannot be negative, should be greater than or equal to 0. The graphs of the equations we have these equations are the lines. For this we call AB, for this we have CD, for this we have EF, for this G is x equals 0, its graph is y-axis, y equals 0, its graph is x-axis respectively. The shaded region EZF with vertices this as in this picture is the feasible region. At E the value of Z is equal to this. At G the value of Z is this. At I the value of Z is this. At F the value of Z is this. For maximum scholarship, number of students of class 11 5 and of class 12 10. That is maximum scholarship T 5 का 10 का lower नहीं. Question number 34. A manufacturer makes two types of cups A and B. Three machines are required to manufacture the cups and the time in minutes required by is given below. Type of cup AB. Machines 1 to 3. Time consuming. Time in minutes 12, 18, 6, 609. Each machine is available for a maximum period of 6 hours per day. The profit on each cup A is rupees 7.50 and on B is rupees 5. How many cups of each type should be manufactured in a day to maximize the profit? Solve the LPP graphically. Graph paper will not be supplied. 6 marks. Let x and y be the number of cup A and B. Then the problem is to maximize z equal to 7.5x plus 5y, subject to the constraints. 12x plus 6y should be less than 6 hours in a day, therefore in minute 36 into 60 we have this inequality. And 18x plus 0y should be less than 6 into 60, that is x should be less than or equal to 20. And 6x plus 9y should be less than or equal to 6 into 60, that is twice x plus twice y less than or equal to 120. And x, y should be greater than or equal to 0. We have formulated. The graphs of the equations, these are the lines A, B, C, D, E, F, Y axis, X axis respectively, as in the figure. The feasible region is shaded region C, P, Q, F, O with vertices this. At O, the value of Z is 0. At C, the value of Z is 150. At P, the value of Z is 250. At Q, the value of Z is 2 162.5. At f, the value of z is 200. Thus, maximum z is 262. 262 at x equal to 15 and y equal to 30. Hence, the maximum profit occurs when number of cup A and B are 15 and 30. Question number 35. A girl throws a dice. If she gets a 5 or 6, she tosses a coin 3 times and notes the number of heads. If she gets 1, 2, 3, or 4, she tosses a coin 2 times and notes the number of heads obtained. If she obtains exactly 2 heads, what is the probability that she throws 1, 2, 3, or 4 with the die? 6 marks. Let x1 and x2 be the events of obtaining 5 or 6, and 1, 2, 3, or 4 respectively. Let A be the event of obtaining exactly 2 heads. Then P of x1 is of either 5 or 6, getting 5 or 6, that is 2 by 6, 1 by 3. P of x2 is also 4 by 6, that is 2 by 3. P of A by x1 is getting 2 heads. It occurs in this form, in this way. So we get 3 by I. P of A by x2 is 1 by 4. Required probability is P of x2 by A. That is this formula using Bayes theorem. Putting their respective values and solve, we get 4 by 7. Thanks for watching.